Welcome dear students. Today we will be starting a new exercise on Pythagoras theorem. So I'm starting today exercise 13b. Okay, so basically in this what you are going to do is you will see some proofs. Okay, some proofs of, you can say or in other words you can say the applications of Pythagoras theorem. Okay, so in this chapter we'll be learning about only the application of Pythagoras theorem. So let's see the first question for the day. So today I am starting with question number 2, which says in an equilateral triangle ABC, AD is perpendicular to BC and BC is given to be x centimeter. Find x in terms of x the length of AD. So you need to find what is AD in terms of x. Okay, so basically here triangle ABC is an equilateral triangle, and all of you know that in an equilateral triangle all the sides will be equal, isn't it? So we have an equilateral triangle out here ABCD. Okay, so here AB, AC, and you know all this BC, all of them are equal to each other. Okay, BD is also equal. Now here it is given that AD is perpendicular to BC. Okay, so this is perpendicular as you can see out here, and it is given that BC is given to be x centimeter. Okay, so that means if this much is x centimeter, if this is x, then this is also going to be x, and this is also going to be x, right? So these are the things that you need to keep in mind. Now you are asked to find how much is AD in terms of x. Okay, so all of you know area of this equilateral triangle is half into base into height. You know area of a triangle is half into base into height. Okay, now see here carefully. Area of an equilateral triangle. Formula for calculating area of an equilateral triangle is root 3 by 4 into side square. So this is the formula which is valid only for equilateral triangle. Okay, and here we have this formula also. This formula for area is for all the triangles, whereas this formula is only for equilateral triangle. Okay, so you know in this formula or in this diagram your base BC is x and your height is AD, isn't it? So that's why in place of height I have written AD here. Okay, so all of you know that measurement of each side is x, right? So that's why I have written x square. Okay, so here simple. Now what you need to do is x and x can be cancelled. Okay, so 2 and 4 also can be cancelled, so it is root 3 by 2. Okay, it is root 3 by 2, and since there is x left, so we have x also. So that's why the value of AD turns out to be root 3 by 2 x. Okay, so I got my value of AD in terms of x. Simple. So you may pause the video and note down your solution. Let's move to next question. So in question number 3, ABC is a triangle right angled at B. That means at B, at point B in triangle ABC, angle is given to be 90 degree. Right angled means 90 degree. Now M is a point on BC, so you need to prove this. So the respective diagram for this will be somewhat like this. Okay, now if you look at this diagram, at B we have got 90 degree. Okay, and it is given that M is the midpoint. M is a point on BC, right? So M is a point on BC. Okay, now you need to prove this AM square plus BC square is equals to AC square plus BM square. So what I have done here is, since it is AM out here, so I'll join A and M, so you get AM here. Okay, so now if you look at triangle ABM, okay, so if you look at this triangle ABM, there your hypotenuse becomes AM. So that's why as per Pythagoras theorem it becomes AM square equals to AB square. Okay, so it is AB square out here, so AB square plus BM square. Okay, so this is your Pythagoras theorem in triangle ABM. Okay, now see from here, can you see that AB square is AM square minus BM square? If you take out here, take BM square out here. Yes, so let me call this as equation number 1. Simple. All right, so now we'll consider another right angle triangle. As you can see, so you remove this AM, So you have got triangle ABC. So in triangle ABC, your hypotenuse becomes AC. So that's why your value becomes AC square is equals to AB square plus BC square. Now from here, if you calculate AB square, you get AC square. Take this out here, you get minus BC square. So let me call this as equation number 2. Now see, here we have left hand side AB square, and here also we have AB square. Both are same, isn't it? So that's why using 1 and 2, I can say that since these two are AB square, I can say that this and this will be equal to each other. Okay, so AM square minus BM square is equals to AC square minus BC square. So what you will do here is you take this out there and you get this out here. So in that case, you get this much, and that's what you are asked to prove, right? So that's what we need to prove, and hence we have successfully proved it. So you may pause the video and note down your solution. Alright, so we have got a long question out here. So let's see what are the things that are given to us. So as per the question, it is given that M and N are the midpoints of the sides QR and PQ of a triangle PQR right angled at Q. So there's a there's a triangle, right angle triangle, where Q is 90 degree. Okay, so you see this is the angle Q which is 90 degree. Okay, now it is given that M, okay, so it is given that M is the midpoint of QR, right? So M is the midpoint of QR and N is the midpoint of PQ. N is the midpoint of PQ. Okay, now question is asking you to prove all these things. Okay, so for that I have joined all these points. Okay, we need PM, right? So where is PM? PM is this one, so I need to join PM. Okay, now you have MN also, so we have to join MN. Okay, you have RN also, you have RN also, so we have to join RN also. So all the joints have been made. Okay, now as I said, we will draw PM, MN and NR. Okay, so now all of you know, see, since M is the midpoint of QR, then I can say that this and this, they are equal. Similarly, this will be equals to this one. Simple. Okay, so that's what is written out here. So Pn is equals to NQ and Qm is equals to Rm. That's what is written out here. Okay, now first we'll apply Pythagoras theorem in triangle PQM. Let's see where is PQM. So we have PQM. So in this triangle, PM acts like hypotenuse. Okay, so that's how you get PM square is equals to PQ square plus MQ square. Okay, so from here, just look at this PQ. If you see PQ, can I write PQ as PN plus NQ? Obviously. So in place of PQ, I have written PN plus NQ. Okay, so now if you look at this, this is in the form of A plus B whole square, isn't it? So all of you know A plus B whole square is A square plus B square plus 2AB, where Pn plays the role of A and NQ plays the role of B. So this represents A square plus B square plus 2AB, and you have MQ square, so MQ square is kept as it is. Okay, now see from triangle MNQ, okay, so where is MNQ? Let's see. So we have this triangle MNQ. So in this case, this acts like hypotenuse, so that's why you have MN square. Okay, so hypotenuse square is equals to perpendicular square plus base square. Okay, now what am I going to do is NQ square and MQ square. So if you add them, you should get MN square. So that's why I'm using this one and this one, and instead of these two, I'm going to write MN square. Okay, so I've written, we have PN square and we have 2PN NQ. So this much is kept as it is, but in place of these two, I have written MN square, and let me call this to be equation number 1. All right, so we have equation number 1 with us. Now again we'll apply Pythagoras theorem in triangle RNQ. So where is RNQ? Let's see. So we have RNQ. It's a similar kind of work. Okay, now this time also we are going to have a similar kind of work. So in this RNQ, Rn acts like your hypotenuse. So that's why you have Rn square perpendicular hypotenuse square equals to perpendicular square plus base square. Now see here carefully, we have RQ, right? So can I write RQ as QM plus RM? Can I write this RQ as QM plus MR or RM? Obviously. So that's what is written out here, and similarly apply A plus B whole square formula. So in that case you get A square plus B square plus 2AB. Okay. Now similarly you know NQ square plus MQ square, right? NQ square plus QM square or NQ square, both means the same. So in place of these two I can write MN square, and the rest are written as it is. Okay, so let me call this as equation number 2. Okay, right. So okay, so I don't have space here, so you may pause the video and note it down till here. Okay, so we will add 1 into. Okay, so let's add 1 into. So in the left hand side you will get this much. It's simple. Okay, in the left hand side you will get this much, and in the right hand side you get this much. Okay, so if you look at this, we have mn square and mn square, so they will get added. So you have 2mn square, okay, is equals to, and these two are kept later. Okay, now observe this here, you know, Pn and Nq, they are same, isn't it? They are same. And here also QM and RM, they are same. So that's why in place of RM, let me write QM. Okay, in place of RM I am writing QM, and in place of PN I am writing NQ or QN. Okay, I am writing NQ. So that's why you get here 2mn square plus, in place of this if I write NQ, you get NQ square. Okay, so in place of RM I have written QM here, and similarly here if you write Pn as NQ, so NQ into NQ becomes NQ square, or you can say QN square. Similarly this becomes QM into QM is QM square. Okay, so therefore if you see here carefully, then what do we have here? We have, right, so you can take 2 common. First and foremost you can take 2 common. Okay, so if you take 2 common, then from here you get 2 into Qn square plus Qm square. Now all of you know Qn square plus Qm square is how much? It is Mn square. Okay, so you have already noted down this is Mn square, so that's why in place of this I have written Mn square, and this much is also same, that is Mn square. Okay, so add all of them. So 2mn square, mn square and 2mn square, when you add all of them you get 5mn square, and that's what you want to find or prove, isn't it? That's what you want to prove. So we have successfully proved it. So you may pause the video and note down till here. Right, so we are still left with 4 more questions. Okay, so we have to do number 2 now. So again we'll apply in triangle PQM. Okay, so in triangle PQM, so in triangle PQM is this one. Okay, so all of you know we have got this much, right? Okay, so if you multiply both sides by 4 you get this much. Simple. Okay, now why am I doing that? Because I want 4 PM square. Okay, and I have got 4 PQ square also with us. Now let's see what can be done. Now see, MQ is equals to half QR. MQ is half of QR, isn't it? Because M is the midpoint. So that's why in place of MQ let me write QR. Okay, so it becomes, in place of MQ if I write half QR, then half whole square is 1 by 4, and we have QR square is QR square. So 4 and 4 gets cancelled, right? Isn't it? So we get, how much do we get? So just wait a minute, this won't be there. Okay, so this won't be there, I'm sorry. So we have this much left. So that's why we have 4 PQ square plus how much is left here? We have QR square left. So this is what we need to prove. Alright, so you may pause the video and note down till here. Let's move to next part number 3. So we have 4rn square, so we need to prove this. It's similar one. Okay, so where do we have Rn? So Rn is present in this triangle. So again, in this triangle, if you apply Pythagoras theorem, you get this much, isn't it? So multiply both sides by 4 because we have 4 out here. So when you multiply by 4, we have this much. So we don't have any problem with QR, 4QR square. We have this much only. But here we have PQ square, whereas we have got this much. So we can write NQ, you know, where is NQ? We can write NQ as half of PQ, right? So NQ can be written as half of PQ. So in that same way, if you do that, okay, then 4 and 4 also get cancelled. So ultimately you get this one, and that's what we are expected to show. Pause the video and note down your solution till here. Now we have got the last part, number 4. Let's see how to do this. Okay, now we know that this is there. This is from the first one. Okay, so we have already proved it. So now if you look at triangle MNQ, all of you know NQ square plus MQ square will be MN square. We know that. Okay, so that's why in place of this, in place of MN square, I am going to write this much. Okay, now let me multiply both sides by 4. So when you multiply both sides by 4, we have 4 into 4. This is not 4.5, this is 4 into 5. Okay, now all of you know NQ is half of PQ and MQ is half of QR. So that's why in place of NQ I have written half of PQ, and since there is square out here, so that's why there is square. Similarly, the same thing is happening with MQ. Now open the bracket, just open the bracket. So you get 1 by 4 out here. Here also you will get 1 by 4. So if you bring that 1 by 4 out here, that 1 by 4 and this 4 gets cancelled. So you have only 5 out here. Okay, and what do you have here? You get PQ square plus you get RQ square. See what is happening. I am just showing you once again. You have 4.5, 4 into 5. Okay, now here this is 1 by 4. This is also 1 by 4. So this 1 by 4 comes outside. Okay, so 4 and 4 gets cancelled. So you have 5. Now PQ square plus RQ square. Okay, see PQ square and RQ square. Won't this be equals to PR square? Yes, obviously, right? So that's why in place of this I have written PR square. Okay, and that's what we are expected to prove. Okay, so we have successfully proved all the 4 parts of this particular question. Okay, so today we'll be doing only this much. You may pause the video and note down your solution till here. Thank you very much.